Hello everyone, this is James Shore with another how-to video. I'm recording this on August 6th, 2015. In this chapter, we are looking at testing our JavaScript. And in the last episode, we just finished getting our code set up, or our automated build set up, so that we could manually test it by typing jake run. And once we do that, we get a little localhost server set up on our localhost 8080. And when we do that, we see our little hello world program up and running. So that's manual testing, but the vast majority of what we're going to want to do in development is automated testing. It is just too slow to manually check your code every time you make a change, especially since the most effective way to write your software is to test every single line of code as you go. Very small steps. That way, when you make a mistake, you find them right away. Well, you just can't do that with manual testing. The bigger your program gets, the longer it takes to test. And we're looking at confirming that our software works maybe every minute or so. And to do that, we need our test to take less than about 5 seconds. And automation is really the only way to do that. Now, there are 3 things we're going to need from our automation. One, we're going to need a way of checking that our code does what it needs to. Those are called assertions. We're going to need a way of grouping those checks into related documented things. Those are called tests. And we're going to need a way to run our tests automatically across browser. We need cross-browser test automation. So those are the 3 things we need. We're going to look at those over the course of the next several episodes. In this episode, we're going to start out by looking at assertions. Let's start out by bringing up our code. So here we are right here. We have this source directory that we just added. Let's go ahead and make a new file in here called test.js. So this is going to be just a simple little program to run a test. And let's make sure that this is included in our linting. So I'm going to take out this semicolon. And if I run our build, the build should fail, but it doesn't. And that's because we haven't told our linting code here in our Jake file. If you remember from our last chapter, we have our lint automation here under the lint task. And the files we lint are determined by this line right here. This will take an array of file globs. So we can say everything in the source directory and all subdirectories, that's what the double star means, that ends with .js should be tested. So this is saying, or linted. This is saying lint the Jake file and all JavaScript files in the source directory and all subdirectories that we may add in the future. Now, if I run our lint, we will get an error saying that we've got that missing semicolon. That's exactly what we want. So there we go. And now you can see that we are linting 2 files here. I'm going to go ahead and check this in. So we're linting all of our JavaScript files in the source directory. So here we have our little test JavaScript that I'm going to use as our example. We're going to build up these ideas, these 3 things that we need: assertions, tests, and test automation. I'm going to build these up from first principles. So when you're writing your code, you're going to write some sort of function. Let's say we have a simple little function to add 2 numbers. We've got an A and a B, and this returns A plus B. Very simple. So simple, in fact, that you'll never really write a program like this. But that's okay. What we need to do is we need to know whether or not this add function works. So we can write a little check that says if add 3, 4 equals 7. So we're saying call the add function, pass in the number 3, pass in the number 4, expect that result to equal 7. Remember in JavaScript we use triple equal. If that works, then we write success. Otherwise we write failure. So there's a simple little check of a function. Now, this is not how testing actually works, but this is, as I said, we're going to build it up from first principles. So this is an assertion. We are calling a function, in this case add, and asserting that the result equals 7. And when we run that, which we can do by saying node source test.js, we get a success. And if we somehow broke the code, we would get a failure. So that's good. That's a basic assertion. Now, that's not how assertions really work. What really happens is we have a result that we get from calling our function 3, 4, and we have an expected result, which in this case would be 7. And we say if result equals expected, well, rather, if it doesn't equal expected, then we throw an error. In JavaScript, you can throw errors. If you've learned in your programming education so far about exceptions, that's what this is. This is an exception. If you're not, well, the throw keyword basically says something went wrong that we don't know how to fix, and we are going to return a value through sort of this side channel called the exception, called throwing an exception, that will cause our program to crash unless somebody else puts in a try block elsewhere. Boy, this is kind of complicated and hard to explain. Let me just show it to you. So what we're going to do here is we're going to say if the result is not equal to expected, we'll throw an error saying that we expected the expected value, but got the actual result. And rather than calling that result, let's call it actual. So this is another way of doing the same thing, another way of doing an assertion. So now, if we run this, nothing happens if it works, which is actually what we want. But if it fails, if we turn this back to not adding, we'll see an error come out. And when you throw an error, if nobody catches it, then what you will get, your program will crash and it will give you this error message. It will show you the line number, give you the error message. So we expected 7, got -1, and give you a stack trace. This shows every line of code that was run by every function, starting at the very top of the program, down through all the different layers of the program into the place, the last line that was run, which was here in test.js, line 9, character 33. So in other words, right here. There's line 9, character 33. Now, if you're not familiar with exception handling, it is possible to catch exceptions by putting a try catch block. Like this. This is called catching an exception. When an exception is thrown, if you want to catch that exception, if you want to prevent your program from crashing, you have to put a try block around either the line that throws it or any other function that ends up throwing an exception down inside of itself. And then after the try, you put catch, and that's where you get the exception. So this is going to be our exception object, which is right here. So if I run this, you'll see it say, caught exception, error, expected 7, but got -1. So this is a basic assertion. We are not actually going to do the try catch. We're just going to let the program crash when our assertion fails. So there we go. Expected 7, got -1. Now it turns out that typing this every time and putting in the expected but got is a little bit painful. So what people do is they have functions that will run to do this comparison for them. Often it will be called something like assert equal. So we could write a function called assert equal and pass in the expected and the actual and basically do this thing. If actual does not equal expected, throw the error. And here we would say assert equal expected, comma, actual. So there we go. We get the same error message. That makes it a little more convenient to write our assertions. Now we can inline this 7. That means we can, instead of having it as a variable, we can just put it here. And instead of having a variable here, we can, again, just bring it down here. And you can see that works exactly the same way. Now it's a little odd having the expected value first, so let's switch those around. Let's put the actual first, the expected value second, like this. So we'll expect add 3, comma 4, 2 equals 7. And then when it doesn't, we get an error. And when it does, our program exits. So that's assertions. That is what assertions do for you. They allow you to check the results of a function. Now, you don't actually write your own assertion functions. This has been done a million times, so there are a lot of third-party libraries out there to do it for you. The most popular right now is called Chai. So that's what we're going to do next. We're going to download Chai and install it and use that instead of actually writing our own. Let me go ahead and check this in first. So we have a basic assertion example. Now what we're going to do is we're going to install Chai. So again, as normal, we say install Chai, save dev, ignore scripts. That's installed. We'll need to do and check that in. So we've installed our Chai insertion library. Do an npm rebuild to make sure there's no binaries, but there's not as usual. Now to actually use this, we're going to require Chai like this. Now Chai is a little bit unusual in that it actually has 3 different types of assertion libraries in it. If we look at the API documentation here on the Chai website, which is chai.js.com, you can see that there's 3 different styles: an expect style, a should style, and an assert style. What's going on here is that there's sort of this, assertions are so fundamental for testing that people have kind of split up into 2 different camps about how to do it. And there's no really good reason for this other than, people like doing their own thing. The assert style looks like what you see here. You can say assert dot equal add 3, 4, 7. And it's just like a regular function. You pass in the actual value first, the expected value second, and you're done. There's also the expect style, which is more like reading English, but a little bit harder to write your own functions. Right now, if you wanted to write your own assert function, you could do it very easily, just as we did here. There's also something called expect, where you can say expect add 3, 4 to equal 7. And that's really cool in that it reads more like English, but it's not so cool in that it's a lot harder to understand what's going on here. This is a normal function call. What is this? Well, it's sort of this object magic. And then taking it even further for really bizarro magic, you can say add 3, 4 should equal 7. And the way this works is by doing things that you really shouldn't do in JavaScript, is by modifying the function prototype to add this should method or variable on it. It's very, very deep magic, and it modifies core parts of JavaScript, which is really not a good idea. It can cause things to break. I just don't recommend it. When you're testing your code, you want to test the code that's going to go into production, and this should approach is not the code that's going to go into production. Anyway, those are 3 different approaches. My preference is for the basic assert. It's nice and straightforward. If you want to write your own asserts, it's easy to do. You can reason about it very well. You understand that this is calling a function. This is very cool, and so is this. I mean, they're both very cool and very fancy, but they're not simple. And the most important thing in programming is to prevent unnecessary complexity, because as your programs get bigger, what's going to trip you up, what's going to cause you problems is not understanding what's going on. You don't want to get to a point where your code doesn't work and you don't know why not. That is what takes hours and hours of debugging. So complexity, cool things that don't add a lot of value other than, being cool, avoid them. And you'll see a lot of people in the JavaScript world, just a huge number of people in the JavaScript world, love cool things that can be done in a much simpler way but aren't fancy. Avoid fanciness, go with the straightforward basics. And to do that with Chai, what we can do is we can say require Chai's assert library, like this. And now this assert.equal, if I've done it right, is equivalent to this old assert.equal. Let's go ahead and try that. This should work. Let's see, we'll need to run our test.js. There, it appears to be working. So let's go ahead and take out this old one. cause the function to break, and there we go. Exact same result. You can see that the error message is a little bit different. Expected -1 to equal 7. I prefer the error message that says expected this but got that. It's just a little easier to read. And in my opinion, the most important thing an assertion library can do is provide really great error messages. And Chai actually doesn't provide great error messages. It just provides adequate error messages. I don't think there is a really great assertion library for JavaScript yet, but maybe there will be someday. At any rate, that is our assertion library, a way of checking what's happening in your program and throwing an error, giving you an error message when it fails. Next, what we're going to do is look at multiple assertions and how to group those into tests. That's coming up in the next episode. In the meantime, your exercise for this episode is to look at the Chai library in more detail. If you look at chai.js.com/API and the assertion portion of the documentation, you'll see that there's a whole bunch of assertions in here that you can run. There's the .equal, which is the one that you'll probably use most often, but all kinds of other useful ones. Take some time to review these and see what you think. And of course, update your code to follow along and write a little function with an assertion on it as well. I'll go ahead and check this in off camera. Thanks for watching, and I will catch you next time.